Hello guys, in this video we are going to learn the types of singular points and how to identify them in a second order differential equation. Now looking at this is a second order differential equation because the highest power order here is 2. Are we okay? So here for a differential equation, to find your singular point, we equate the coefficient of the highest order, which is this, to 0. So the coefficient, we equate it to 0 and then we find our singular point. So here we equate the coefficient of the second order differential equation, we equate it to 0 and then we find our singular point. So then we say S0 is what? A singular point. So the types of singular point we have is regular and then irregular. So in this video we are going to focus more on irregular and what? Non-regular or irregular singular point. Now considering a second order differential equation, so this is our second order differential equation. Before we continue to look at the regular and irregular singular point, we make sure we find the standard form of the equation. So to find the standard form, we divide by coefficient of the second order, which is a0 x0. So here we divide the equation by what? A0 x0. So when we divide this, we'll cancel, the coefficient will now be 1, and then this will be this, and then this will be this. So when you divide by this, it will become 0. So this is the standard form. Now what we do next is that we just let our new coefficient of y prime to be p, and then for y to be q of x. So our new equation is now y prime prime px y prime plus qx y equal to 0. Now to check whether the singular point is regular or irregular, what we are going to do is that we have a condition for it. If both x minus x0 multiplied by p of x and x minus x0 all square multiplied by q of x are finite, or if it clears the singularity at x equal to a0, then at x equal to c, we say it's a regular singular point. Are you okay? So we are going to look at example and then we get more understanding of this topic. So I have an example here. So this is our second order differential equation because the highest order here is 2. So we have to find the singular point and then show whether that singular point is regular or irregular. So what we are going to do first is that the highest order coefficient, we equate it to 0. So our highest order coefficient here is what? Is this. So we equate it to 0. So we are now going to look for what? Our singular point. So when you do this, we find the value of x, you get what? Plus or minus 3. So plus or minus 3 becomes our singular points. Are you okay? That means when we substitute 3 or minus 3 here, it will make the equation undefined or 0. Are you okay? This will become 0. When you divide by this, it will become 0. When you divide by this, it will become what? 0. So our plus 3 and minus 3 are our what? Singular point. So what we are going to do next is that we are going to write this equation in a standard form. So you just divide by the highest order, which is this, and then we divide through the equation. So when you do that, we are going to get this. So we now know our p of x will be this and our q of x will be this. Now we also know our singular points to be 3 and then minus 3. So we are going to check whether 3 or minus 3 is a regular or irregular singular point. So this is how we are going to test for that. So our first singular point is this. Now the condition states that if we multiply x minus x naught by p of x, and then x minus x square multiplied by all square multiplied by q of x, and then it clears the singularity at what x equal to x naught, then we say it's a regular singular point. So we are going to apply that rule here. So looking at this, we have this to be our p. We know our p is this. So what we just expand this. When we expand it, this difference of 2 square, so we are getting this square. Are you okay? So the square will affect all, will affect this, and then will affect this. So you know this x plus 3, it will cancel one of this, so it will left with this. So this is now our new p of x. Are you guys okay? So this is our p of x. So you multiply by what? X plus 3. So this is what? Minus. When you bring it to become plus. So when you do this, this will cancel this, and then our new equation will now be 1 over x minus 3 all square. So looking at this, you can equate this to 0. When you equate this to 0, that means we are finding our new singular point. When you equate this to 0, our new singular point will be 3, which is not the same as this. Are you okay? That means it clears the singularity at what x equal to minus 3. Now for the q of x, we are going to square this, and then we multiply by our q of x. So when you do this, this will cancel this, so it will left with 5 over this. And then when you find the singularity, that means we equate the denominator to 0, our s will be what? 3, which is not the same as this. That means it clears the singularity at what? X equal to minus 3. So this is what our regular singular point. So this becomes our regular singular point. Are you okay? So now let's test for the second, which is s is equal to 3. We have to show whether it's regular singular point or irregular singular point. So the same idea here, we are going to apply the same thing here. So x minus 3, because it's positive, it will become negative. So when you use to multiply this, one of this will cancel this, so it will left with this. Are you okay? So when you do this, when you equate the denominator to 0, we are getting 3 and then negative 3. Now looking at this, the singularity here is what? 3 and then negative 3. So the 3 is the same as the singularity for the previous one. So we can say this is what? The rule, the condition is not satisfied here. So we say at x is equal to 3, that's the singular point, is what? Irregular singular point. Are you guys okay? So what it means is that our singular point here, negative 3 is a regular singular point, and then positive 3 is irregular singular point. Thank you guys for watching. Thank you.